Hello everyone, welcome to TechnoGate. In the previous lecture, I have given you a basic introduction regarding the index properties of the soil. What is the meaning of index property and what are the index properties? We have discussed the name of those properties. Now, one by one, we'll start our discussion with all those properties. Just to make you remind that we have classified index properties in two different categories: soil grain properties and soil aggregate properties. Grain properties were the properties of a single soil particle, and in that we'll be dealing with the weight of the particle, or in the form of specific gravity. We'll be dealing with the shape of the particle, we'll be dealing with the size of the particle. In the second category was soil aggregate properties, that was the property of the entire soil mass, and in that particular thing we'll be dealing with the properties like density index or relative density, consistency, sensitivity, activity, thixotropy, permeability and shear strength. But permeability and shear strength will not be dealt in this particular chapter. We'll be dealing permeability separately in detail in a new chapter. The entire chapter will be of permeability, and similarly we'll be dealing shear strength in detail in a new chapter, that will be a chapter of shear strength. Apart from permeability and shear strength, we'll be dealing with relative density, consistency, sensitivity, activity and thixotropy in the category of soil aggregate property. So we'll be starting our discussion one by one with each and every property in detail. We'll discuss the meaning of the property, we'll discuss how that property can be calculated, we'll discuss the practical significance of that property and how that property can be used to classify the soil also. So I'll be starting my discussion with the soil aggregate properties. I'll be starting my discussion with soil aggregate properties. Soil aggregate properties. What are the properties which will be dealt under this chapter, this topic? The first we'll be dealing with is known as relative density. The second that we'll be dealing with is consistency limits. The third one will be the sensitivity of the soil. Fourth, activity of the soil. And fifth, thixotropy of the soil. We'll be dealing with 5 properties. Permeability and shear strength will not be dealing with. So I'll start my discussion with the relative density. In this chapter, in this lecture, we'll be discussing the concept related to the relative density of the soil. What is the meaning of relative density and how this property can be used to classify the soil. All these things will be discussed in detail. So let us start the discussion of relative density now. So the topic of our discussion is relative density. The topic of our discussion is relative density. This property comes under the category of soil aggregate properties. The entire index properties were classified in two categories: soil grain properties and soil aggregate properties. We have started our discussion with soil aggregate properties, and in this soil aggregate property we'll be dealing with relative density in this lecture. See, what is relative density? Relative density, the another name for relative density is density index. The another name for this property is density index of the soil, and it is denoted by ID. This is the standard notation for relative density or density index, whatever you can say. It is denoted as ID. What is this relative density? What is the meaning of this relative density? Let me make you clear. The first thing which you must remember for this property is, this property is valid only for coarse grained soil. The first thing which you must remember. This property is valid only for coarse grained soil. Coarse grained soil means either gravel or sand. The detailed meaning of coarse grained soil will be discussed in the next chapter, that is soil classification. As of now, so you must be knowing that coarse grained soil simply means gravel or sand. But the exact meaning of coarse grained soil will be discussed in the chapter of soil classification. So the first thing, relative density, the property of relative density is valid only for coarse grained soil. Only for coarse grained soil. You cannot use this property for fine grained soil. Fine grained soil means silt and clay. You cannot use density index or relative density to classify fine grained soil. This property, density index, can only and only be used for the classification of coarse grained soil, that is gravel or sand. The first thing which you must remember. Now, what is the meaning of relative density? What is the meaning of relative density? Let me make you clear. Suppose I have a soil sample with me. I am having a soil sample with me. I have taken this soil sample from a ground in front of my house. I am just giving you an example. I am having 2 to 3 kg of soil sample with me. From where the soil sample was taken? The answer is I have taken the soil sample from the ground situated in front of my house. Okay. Now, the sample which I am having, the sample will be measuring around 2 to 3 kg, or it can be 5 kg, 10 kg. That's not a big deal. You can take out as much as sample you want from the soil, from the ground in front of your house or from anywhere. Suppose I am having some sample with me. The weight of that sample is, I am just quoting a value. It can be 3 kg, it can be 4 kg, it can be 5 kg, it can be 20 kg, anything. I am having a sample with me. Okay. Now, what I am doing, I am having a container with me in my laboratory. I am having a container with me in a laboratory, and the dimensions of this container is known to me. The dimensions of this container is known to me, and if the dimensions of the container is known to me, will I be able to calculate the volume of that container? Simply, I can calculate the volume of that container. Let us say the volume of container is V. The volume of this container is V. What I have to do with this container? The sample which I am having in my laboratory, I'll take that sample and will fill that sample into this container. Simply take the sample and just simply put that sample in the container without making any effort. I'm not forcing the sample to be kept inside this container. I'll simply take out the sample and will keep this sample with a loose hand inside the container, and will try to fill the entire container with my soil sample. I have not applied any kind of load to compact that sample. I have not applied any loading to compact that sample. I have simply taken the sample, and with a light hand I have just kept that sample inside the container so that the container gets filled with my sample. Can I say the sample which I have put in this container will be in a loose condition? Because I have not applied any force to compact that sample. So initially what I have done, the soil sample is filled in the container. Initially, the soil sample is filled in the container in loose condition. Initially, the sample will be filled in the container in loose condition. And just make sure this sample should be perfectly dry. Make sure the sample which you are having should be perfectly dry sample. It must not be having any trace of water in it. The sample should be perfectly dry. So what I have done, I have taken the sample from the ground, around 5 kg, 10 kg, whatever is the value. I have taken the sample and simply kept that sample with a loose hand inside this container, and will fill this container with the soil. So initially the soil sample was filled in the container in the loose condition. Let us assume the weight of the sample filled in container, let us say it is W. The weight of the sample which is filled in this container is W. The soil is in the loose condition, and since the soil was dry, can I say this weight will be equal to Ws? The soil is dry. The total weight of the soil comprises of only two factors, weight of the water and weight of the solids. Since the soil is dry, the weight of the soil will be equal to weight of the solids only. So the weight of the sample which was filled in a loose state in this container, the weight is Ws. What will be the volume of the sample that has been kept inside the container? The volume of the sample will be equal to the volume of the container. So I am having the weight of the loosely filled soil, I am having the volume of the loosely filled soil. So from weight and volume, can I calculate the unit weight of this soil? Can I calculate the unit weight of this soil? And which unit weight I will be having? Since the sample was dry, the unit weight which I will get will be a dry unit weight. So I can simply say that gamma D of the loose soil sample is Ws upon V. I can calculate, I am having the weight of the sample, I am having the volume of the sample, and since the sample was perfectly dry, the unit weight which I will be getting will be the dry unit weight. And why I have written loose over here? Because the soil was filled inside the container in a loose state. So I will get gamma D for the loose soil, that is Ws upon V. Got this? And I also know that gamma D of any soil is equal to G gamma W upon 1 plus E. Gamma D of any soil is equal to G gamma W upon 1 plus E. We have derived this relation. What I have got with my experiment? With the experiment, I have calculated the value of gamma D loose, and that was equal to Ws upon V. This I'll be having some numerical value of this. Can I equate this term with G gamma W upon 1 plus E? And what will be the void ratio in this case? Can I say the void ratio will be maximum under this condition? The soil was loose. The soil was filled in the container in a loose state. So when the soil is in a loose condition, can I say the void ratio will be maximum? So from this expression, I am having the value of Ws, weight of the sample that was filled in the container. I am having the volume of the sample. I have calculated the specific gravity of that sample already. By using pygnometer method, I have calculated the specific gravity. I know the value of gamma W. From this expression, can I get the value of E maximum? I'll be easily getting the value of E maximum. This is our first step. This is the first step to get the value of relative density or density index. See, I am not giving you the direct definition of density index because it will not make any impression. It will not be of any use. If I simply write the definition in 2 lines, write the formula and simply finish it off. What actually we want to do? We want to learn each and every concept in detail. We want to know the practical significance of that particular concept, any concept. So therefore, I am giving you the detail of each and everything. So I think up till here, the things are clear to each and every one of you. Now what I have to do? So initially what I have done, I have simply filled this container with the soil in a loose state. I have simply filled this container with a soil in a loose state. Now what I'll do? So from this condition, I'll be able to get the value of gamma D, that is dry unit weight of the soil which was in a loose condition, as Ws upon V. I can easily calculate the weight of the soil filled in this container. I'm having the volume of the container. The weight upon volume will give me gamma D. And by using the relation gamma D is equal to G gamma W upon 1 plus E, I'll be easily getting the value of E. And since the soil was in a loose condition, the value of void ratio which I'll be getting will be the maximum value of the void ratio. Got this point? Now, second thing, what I'll do now, I'll again see this container. This was the container, same container. I am having the volume of container. I am having the volume of container as V. Now what I'll do, the sample which I was having, I'll try to fill the sample in this container in the densest possible state. I'll apply the force on this sample so that I can kept as maximum as soil. I can fill as maximum as soil in this container. I'll apply a force to densify the soil which was filled in the container. So I'll again fill this container with the soil, but by applying the force so that I can fill this container with as maximum as soil possible. So the soil will again be filled in a dense condition. I'll keep the soil, I'll fill the soil, apply a force so that the soil densifies. Again I'll fill some soil, again densify so that this container is filled with the soil and the soil will remain in the densest possible condition. Again, what I'll do, fill the container with dry soil sample by applying some force so that the soil may get densify. So that the soil may get densify. Again I will calculate the weight of the soil which was filled in this container. Weight of soil filled in container in dense condition. Let us say the weight is Ws. Let us write this as Ws1. Okay. And now the weight is Ws2. More and more soil can be filled in this container once I densify the soil. So let the weight of the soil that was filled in the container under the densest state is Ws2. Volume of the soil will still remain the same. Volume of the soil will still remain the same as volume of the container. So from this, I am having the value of weight of the soil. I am having the volume of the soil. From weight and volume, can I again calculate the unit weight of the soil? And since the soil was dry, the unit weight which I will be getting will be the dry unit weight. So I'll calculate the dry unit weight, and this dry unit weight of the soil will be under the dense condition, and it will become Ws2 upon V, and I can write this as G gamma W upon 1 plus E, and this E will now become minimum because my soil was in the densest state. So from this expression, I am having weight of the soil, I am having volume of the soil, I am already knowing the value of G, I know the value of gamma W, the value of E minimum can be calculated. I will be able to calculate the value of E minimum. So what I am having till now? I am having the void ratio of the soil under loosest condition. I am having the void ratio of the soil under densest condition. These two things I am having. Now what I will do? I will now go to the ground from where I have taken the sample. I will now go to the ground and will perform core cutter method to calculate the bulk unit weight of the soil into the ground. The soil which I am not performing the, first of all what I have done, I have taken the sample from the ground, and from that sample I have calculated the value of E maximum and E minimum in the manner which I have told you. Now what I will do, in the third step, in the first step I have calculated E maximum, in the second step I have calculated E minimum. Now what I will do, I will now take a core cutter and will go into the ground from where I have collected the sample, and on that ground I will perform the core cutter experiment in order to calculate the bulk unit weight of the soil which was present into the ground. So step number 3. Then we will calculate bulk unit weight of soil present in ground by using core cutter method. We will calculate gamma of the soil by performing the core cutter method. है ना? Once I use core cutter method, I will be getting the value of gamma. Can I calculate the water content of the soil that was present in the ground? Because the soil which was present in the ground, I was not sure that the original soil which was present in the ground was dry. The sample which I have taken from the soil, from the ground, was dry. If it was not dry, I have made it dry. But the soil which is actually present in the ground is not sure, we are not sure that that soil was dry. So what I'll do, I'll perform the water content experiment also and will try to calculate the water content of the soil which was present in the ground. Also calculate water content of soil present in ground. So the soil which was in the ground, for that soil I am having the value of gamma and I am having the value of water content. Can I get the value of gamma D for the soil which was present in the ground, and that will be equal to gamma upon 1 plus W? This is the expression which I have already derived. Gamma D is equal to gamma upon 1 plus W. From this I will be getting the value of gamma D of the soil that was present in the ground. Got this? So from this gamma D ground, I am having this value. Can I calculate again the value of void ratio from here? I am having gamma D ground. Can I calculate the value of void ratio? Can I say this void ratio will be the void ratio of the soil which was in the natural state? Because this calculation was done for the soil which was present in the ground. So the soil which is present in the ground is actually the soil which is in a natural state. The sample which I have taken from the ground will be a disturbed state, will not be in a natural state. But since I have performed this experiment, I have calculated gamma and water content of the soil which was present in the ground. By going into the ground, I have performed the core cutter method. So the gamma D value which I will be getting from this formula will be the value of gamma D for the natural soil, and the void ratio which I will be calculating by this formula, gamma D ground is equal to G gamma W upon 1 plus E, will be the void ratio of the soil under natural condition. This will be the void ratio of the soil under natural condition. So I am having 3 void ratio. The void ratio under natural condition, void ratio under loosest condition, void ratio under densest condition. For the same soil, I am having 3 void ratios. The void ratio under the natural state, void ratio under the densest state, void ratio under the loosest state. So from these three values, I am having E minimum, I am having E maximum, and I am having E. E, that is the void ratio under natural condition, and E minimum, this is void ratio at densest condition, and E maximum, this is void ratio at loosest condition. I am having three void ratio now. By using these three void ratios, I'll calculate the value of density index of the soil by using the relation ID density index is equal to E maximum minus E upon E maximum minus E minimum. You can multiply this value by 100 to get the value in percentage. So this is the formula to calculate the density index of the soil. E maximum minus E upon E maximum minus E minimum. This will give you a numerical value. Now the question comes, what is the significance of this value? See, what I am doing actually, I am actually trying to compare the void ratio of the soil, natural soil, with respect to the void ratio under the densest and loosest condition. See, simple mathematics. Suppose this is a number line. This is a number line. Somewhere here I'll be having E maximum for that soil. Somewhere here I'll be having E minimum for that soil, and somewhere in between I will be having the void ratio of the soil under natural condition. So this is the void ratio of the soil under natural condition, this is the void ratio under loosest condition, densest condition, and this is the void ratio under the loosest condition. So the value of density index actually tries to give me the nature of the natural soil, whether the natural soil is in a loose condition, whether the natural soil is in a dense condition. So the practical significance of density index or relative density is simple as that. The value of relative density will give me a basic information regarding the denseness or looseness of a natural soil. Density index gives me the general identification of the denseness and looseness of the natural soil. How? Just see. I am having the formula ID is equal to E max minus E upon E max minus E minimum. Just see. Suppose let ID is equal to 0. Let us assume that ID is equal to 0. By seeing the formula, if ID is equal to 0, can I say E maximum is equal to E? If this ID is 0, that means the numerator is 0, and if numerator is 0, that means E maximum will be equal to E. What is the meaning of this? What is the meaning of this thing? If E maximum is E, what was E maximum? What was E maximum? Void ratio at loosest condition, and this was void ratio at natural condition. If ID is equal to 0, I have assumed that if ID is equal to 0, that means E maximum is equal to E. What was E maximum? It was the void ratio under the loosest state. And what is E? It is the void ratio under the natural state. That means, can I say if ID is equal to 0, the natural condition of the soil is itself the loosest condition? The soil, the natural soil which was present in the ground is itself in its loosest state. Bhai, if E maximum becomes equal to E, or if E becomes equal to E maximum, can I say the soil which was present in the ground, which is present in the ground, is itself in its loosest condition? है ना? So this is the practical significance. What I have got from this? What I have got from this? See. This signifies that the natural soil is in its loosest state. The natural soil is in a loosest state. Why? Because the natural void ratio of the soil is now becomes equal to the void ratio under the loosest condition. Got this thing? Again, see one thing more. Let us assume that if ID is equal to 1, what was ID? ID is E maximum minus E upon E maximum minus E minimum. If ID is equal to 1, that means numerator and denominator are equal. Let us equate numerator and denominator. E maximum minus E becomes equal to E maximum minus E minimum. E maximum will be cancelled out from both the sides. You will get E is equal to E minimum. What is the meaning of this? E becomes equal to E minimum. What is the meaning of this? This was the void ratio under natural condition. And this is the void ratio under densest condition. Yeah, densest state, whatever you can say. That means, can I say if the density index of the soil becomes equal to 1, if the density index of the soil becomes equal to 1, can I say the natural soil is in its densest state? If ID is equal to 1, can I say the natural condition of the soil is in its densest state? So the practical significance is, if ID is equal to 1, that means natural soil is in its densest state. The natural condition of the soil is in densest state. Got this thing? This is the practical significance. So, I hope this must be clear. Each and everything related to the density index of the soil must now be clear to each and every one of you. What is the meaning of density index, how the density index is being calculated, and what is the practical significance of density index. Now, I have the range for density index now. It will be between 0 to 1, or in percentage it will be between 0 to 100. 0 means loosest state, 1 means densest state. Any value between 0 to 1 will be an intermediate value between the loosest and densest condition of the soil. Now, how this value can be utilized for the classification of the soil? Since it's an index property, density index is an index property, how this property can be utilized to classify the soil? For this, I'll give you some certain values of density index, and from those values you can classify your soil. See how. I'm writing over here some values of density index. Here I am writing the value of density index in percentage, and here I am writing the nature of soil. If the density index is 0, the soil is in a loosest state. If the value is between 0 to 15%, then 15% to 35%, 35% to 65%, 65% to 85%, 85% to 100%, and 100%. If the value is 0, the soil is in a loosest state. Okay? And if the value is 100, if the value is 100, the soil is in a densest state. Then what about these values? If the value of ID is between 0 to 15, it will be in a very loose state. 15 to 35, loose. 35 to 65, slightly dense. 65 to 85, medium dense. 85 to 100, dense, and 100 densest. So in this way, I can use the value of ID to classify the soil. See, the classification of the soil does not merely means gravel, silt, sand and clay. This is a kind of a classification, but the soil can be classified in n number of ways. This is one classification. On the basis of the value of density index, I will be able to classify the soil. If the value of ID comes out to be 0 for a soil, the soil will be named as the loosest soil. 0 to 15, very loose soil. 15 to 35, loose soil. 35 to 65, slightly dense. 65 to 85, medium dense soil. 85 to 100, dense soil. 100, densest condition wali soil. The soil under densest condition. So in this way, I can use the concept of density index or relative density to classify the soil. I hope the term density index, the meaning of density index, the formula for density index, practical significance of density index, and how the density index can be utilized to classify the soil must be clear to each and every one of you. So this is all about the meaning of density index of the soil. In the next lecture, we'll continue our discussion with the next index property of the soil. Thank you.